Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be doing Unit 10, Lesson number 10, on polynomial long division. Now, that kind of sounds a little scary, polynomial long division, but keep in mind that what we're trying to really do throughout this entire unit with rational expressions is that we're trying to make the link between what we do with integers, such as simplifying fractions, multiplying, dividing, things like that, and what we do with polynomials. Polynomials are to integers as rational expressions are to fractions. And one of the things that you learned how to do, granted it was maybe a few years back, was how to divide two integers using long division. Today, we're going to be learning how to divide two polynomials by using exactly the same algorithm. So, let's take a look. Okay, exercise 1 is all numerical. And in exercise 1, it says consider the division problem 1519, 1519 divided by 7, which could also be written as this, and it could be written this way as well. Now letter A says find the result of this division using the standard long division algorithm. Is there a remainder in this division? So that's right, we are using the standard long division algorithm. So write this down. Okay, let's review how to do this. Now remember how you want to think about this. You want to say, well, does 7 go into 1? The answer is no. How about 7 into 15? Sure. 7 goes into 15 two times. Now what do you do with that 2? Well, you multiply it by 7, right? You get 14. Then what do? You subtract and you get 1. Then what do? Well, you drop this 1 down, and then you start all over. How many times does 7 go into 11? Well, it goes in there 1 time. So we get 7, and we subtract and we get 4, and then we bring the 9 down and we get 9. We say how many times does 7 go into 49? And that's 7 times. Then we do 7 times 7 and we get 49 and we get 0. And then we're done. Is there a remainder? No remainder. Or maybe it would be better to say a 0 remainder. But most people would say no remainder. So, 1519 divided by 7 is 217. Now this next piece is very, very important. Letter B, which often is up here but down here on this worksheet, says rewrite your result from letter A. So we're going to rewrite this result from letter A as an equivalent multiplication equation. All right? Now what does that really mean? It says, like somehow, I want to say 1519 divided by 7 equals 217. I want to write that equivalently in multiplication terms. How would you do that? Pause the video just for a second. All right. Well, what that really means is that 1519 is 7 times 217. That's it. Or likewise, 1519 is 217 times 7. Whichever way. All right. Now that one was pretty easy because the remainder was 0. Now let's take a look at a division problem that has a remainder in it. All right, let's walk through it again together. Now we're going to do 1522 divided by 7. Now this is actually very close to what we did before. Whoops, except apparently I'm going to botch it. I'm going to have a 2 there, and I'll have 14, and I'll subtract, and I'll get 1. And then I'll have 12 here, and I'll put a 1 there, and I'll put a 7 here, and I'll subtract, and I'll get 52. Now 7 doesn't go into 52 nicely, but the closest I can get is 7. And that's going to give me 49, and when I subtract, I'm going to have 3. Now there's nothing left here to drop down, so I'm done. So what do I say? Well, I say that 1522 divided by 7 is equal to 217. Do you remember this? With a remainder plus a remainder of 3. Now, I've never really liked that much, but think about what that really means. It means like if we had 1,522 items and we were putting them into 7 boxes, we'd have 217 in each box, 217 in each box, and then there would be 3 that would be left over, 3 that were remaining. But it's actually very, very important that you actually understand that 1522 divided by 7 is 217 plus another 3/7, right? Or if you want to write it in kind of mixed numbers, 217 and 3/7. All right? I like this form the best. Okay? Now, what does this mean in terms of what we did down here? I want to write down something very, very similar to this. Well, see if you can write down something similar. Write down this fact, 1522 divided by 7 equals 217 plus 3/7. How can that be written as a multiplication equation? Well, here it is. It's 1522, well, that's equal to 217 times 7, but plus an additional 3, right? Or 1522 is 7 times 217, plus an additional 3. All right. Just a little review of numerical long division. Pretty soon, we're going to pop into polynomial long division. So pause the video now and make sure you understand this before we move on. Okay, I'm going to clear it out. All right, now let's see how it works when we divide two polynomials. Letter A. Simplify the following by performing polynomial long division. All right, here it goes. Now we are going to do this as similar as we possibly can to what we were just doing. But of course there's a big difference because now you're looking at this and going, how do I even start? So let's talk about how you start. All right, all I want you to do is look at this x and look at this 2x squared. Whatever I put up here is going to then multiply the x plus 6 just like it did before. And I need to get rid of the 2x squared. So I need to put something up here that when I multiply by x gives me 2x squared. Let me say that again. Whatever I put up here, when it multiplies by x, has to give me 2x squared. And that's of course going to be a 2x. Now remember, just like before, I'm going to multiply this. So 2x times x is 2x squared plus 2x times 6 is 12x. And now I'm going to subtract. Now 2x squared minus 2x squared is 0. Actually, I'm not going to write that 0 there. I'm going to now have 15x minus 12x, and that's going to be 3x. I'm not adding them. I'm subtracting all of this. Now, for some people, that can be very tricky. So if that's a problem for you, what I would do is just change the signs and add. And then you add. Okay? I'm going to go back to blue. Then I drop this down, plus 18. What do I do next? I now look at this 3x and this x. And what do I put up here? I put plus, because I have to have it positive, 3. Why do I put plus 3? Because 3 times x is 3x. Right? I got to match those up. These two have to match. All right? Then 3 times 6 gives me 18. And now when I subtract, 3x minus 3x is 0. 18 minus 18 is 0. So I get 0. So in other words, 2x squared plus 15x plus 18 divided by x plus 6 equals 2x plus 3, right? But part B says write the result you found in A as an equivalent multiplication equation. Wow, you should be getting pretty good at this. Pause the video now and rewrite it. All right. Well, it just means the following. 2x squared plus 15x plus 18 equals 2x plus 3 times x plus 6. Now, what we really were just able to do is we just used this to factor this. And in fact, this will be the first time of many times I point this out. The fact that there was a zero remainder means that what we were dividing by, x plus 6, was a factor of 2x squared plus 15x plus 18. All right, that's what factors really are. Factors are numbers that when you divide other numbers result in no remainder, zero remainders. All right. Now let's deal with the case where we do have a remainder. See how similar this is to the last problem. All right. It says write 2x squared plus 15x plus 20 divided by x plus 6 in the form q of x plus r divided by x plus 6, where q of x is a polynomial. We should know what that means. R is a constant by performing long division. All right, so let's do it again. Plenty of practice in long division today, but I want to take this very, very slowly. Now again, it's going to play out very similar to this one, almost identical. So I need to figure out what I multiply x by to get 2x squared. That's 2x. So I get 2x squared plus 12x. I subtract 2x squared minus 2x squared is 0. 15x minus 12x is 3x. Again, I want to make sure that this matches up, so I have to put a plus 3. So 3 times x is 3x. 3 times 6 is 18. But now when I subtract, 3x minus 3x is 0, and 20 minus 18 is 2. All right? That now means that 2x squared, so this is my remainder, right? That means now that 2x squared plus 15x plus 20, all divided by x plus 6, well, that's equal to 2x plus 3. That's my q of x plus my remainder, which is 2, divided by x plus 6. This is what in the business we call the quotient remainder form. The quotient remainder form of a rational expression, right? The quotient being this part, let me circle it in red, and the remainder being this part. Okay. Now you're probably still a little bit confused about just how to do polynomial long division, so we're going to work with that a lot more. Don't worry about it. Backside of the sheet, many more examples, and then we'll be doing quite a few in the next lesson as well. But take a look at this, pause the video, and write anything down you need to. Okay, let's clear out the text. Backside of the sheet. All right, exercise 3. Write each of the following rational expressions in the form q of x plus r divided by a form. So we're going to write these in their quotient remainder forms. Okay? So let's do it. All right. Oh, yeah, I think we'll stick with black. That works just fine. Let's do x squared plus 2x minus 5. That almost looks like a square root. I apologize for that. It's not meant to. Let me get rid of this little teeny tiny tail there. All right, let's do it. Now again, the way that you're going to do this is you want to get rid of the x squared. So I'm going to put an x here because x times x is x squared. Then I'm going to do x times negative 3, and I'm going to get negative 3x. Now this is very dangerous at this point because I'm subtracting a subtraction. All right, this is where most students find it way more helpful to change the sign on both of these and then add. All right, So when I add, x squared and negative x squared cancel, and then I get a 5x here. I'm going to drop down that negative 5. Now I have to think about the 5x, so I'm going to put a plus 5 here. Then there's going to be a 5x minus 15. And again, I have to subtract, and that confuses students a lot of times. So it's sometimes easier to just turn that into a negative, turn that into a positive, get rid of this, and add. All right, 5x plus negative 5x is gone, and negative 5 plus 15 is positive 10. And that's it, that's my remainder. So at the end of the day, my final answer here is x plus 5 plus 10 divided by x minus 3. Now, one thing I realized in the last problem was I never wrote that last one out as an equivalent multiplication problem. I apologize for that. It's very difficult for me to go back and correct that now. This is my final answer in this problem. In other words, x squared plus 2x minus 5 divided by x minus 3 is equal to this. But if I wanted to write this as an equivalent multiplication statement, it would be the following. X squared plus 2x minus 5 is x plus 5 times x minus 3 plus 10. Okay, this is the equivalent to this in terms of a multiplication sentence. All right, I wanted to loop back from that last one. Lots of different colors. Why don't you try letter B on your own? Pause the video now. Okay, let's work through it. All right, we have 2x squared minus 23x plus 17. And I'm going to divide that by x minus 10. I have to get rid of the 2x squared. I'm going to put a 2x up here. 2x times x is 2x squared. 2x times negative 10 is negative 20x. Again, subtracting a negative. If it's a problem for you, make this negative, make this positive, and add. Those two eliminate. Going back to black, this will leave me with a negative 3x plus 17. I've got to match up that negative 3x because I'm going to be subtracting it from itself. So I'm going to get a negative 3, which is going to give me negative 3x plus 30. All right, I need to subtract. Again, it may be easier to change the signs and then add. In that case, these cancel. 17 plus negative 30 is negative 13. There's my remainder. All right. So my final answer is going to be 2x minus 3 minus 13 divided by x minus 10. Quotient remainder form. 2x minus 3 minus 13 divided by x minus 10. It's also completely okay to say plus negative 13 divided by x minus 10. Either way, doesn't really matter. This maybe is even more appropriate because then you can really see that your remainder is negative 13. All right, pause the video now and write down anything you need to. Okay, I'm going to clear out the text. Exercise 4. Now, so far we've been doing polynomial long division in order to write things in quotient remainder form. Some of the problems you can do by just taking advantage of, let's say, some structure and some kind of cool manipulation. All right, and let's take a look at that because sometimes that's easier than polynomial long division. You can still do polynomial long division on these, but sometimes it's easier to do it in a different way. Let's take a look at this very simple expression. X plus 8 divided by x plus 3. It says write the numerator as an equivalent expression, the numerator, this guy. I want to write an equivalent expression that involves x plus 3. Well, one way to do that is to take my 8, right, and break it into 3 plus 5. I think everybody would agree that that 8 is the same as 3 plus 5. But one of the great things, and maybe I'll leave it like this, one of the great things about addition is it's associative. So I can make that x plus 8 into an x plus 3 plus 5. So let me just stop here. Now it says use the fact that division distributes over addition to write the final answer. In other words, I can take this thing and I can say, well, I'll take x plus 3 and divide it by x plus 3. And then I'll take 5 and divide it by x plus 3. But x plus 3 divided by x plus 3 is 1. And now I have it. There it is. I don't know why I have this x plus 5 here. That should be a plus 3. My apologies. But that's it. All right, simple enough. Take a look at what we have, and then we're going to move on to another one like this. All right. Never be afraid to break up addition into addition of smaller components. Okay, let's take a look at some that are a little bit more challenging. I like these a lot. Okay, now again, what I'd like to do is somehow work this out so I don't have to do polynomial long division. And somehow that x plus 2 is going to have to cancel. So ultimately, what I'd kind of like is something that might look like this. 4 times x plus 2 plus something, all divided by x plus 2. I'm predicting where I want to go with this, right? Because then when I break it up, those x plus 2's would actually cancel. Well, what is 4 times x plus 2? That's, 4x plus 8. So I could write that numerator as 4x plus 8 plus 5, right? Because these two added together are 13. And now I can break this up as 4x plus 8 plus 5, again, addition is associative. And now I can distribute that division. So I'd get 4x plus 8 divided by x plus 2 plus 5 divided by x plus 2. And if I factor this, empty void, those cancel, and I'll get 4 plus 5 divided by x plus 2. Isn't that cool? We're taking advantage of the fact that addition is associative to break things up so that we can easily cancel factors, easily write it in quotient remainder form. Now you could do this every time instead of polynomial long division. Here it's relatively simple. Pause the video now and see if you can do letter B. All right, well, as usual, I gave you guys the hard one. Again, the idea is there's nothing much we can do about this 3. All right, ultimately, I'd like somehow to have 3 times x minus 4 in the numerator, right? And that's 3x minus 12. So that's what I want. That's what I'd like to get. All right, so let's play around with that. Well, if I had a 3x minus 12 in the numerator, what else would I have to have so that I really had a minus 5? Well, it'd be a plus 7, right? So negative 12 and positive 7 is negative 5. And then I'd have the x minus 4 in the denominator. Okay, and again, all I'm really doing is taking negative 5 and breaking it into negative 12 and positive 7. Now again, some students might say, well, how do you know you should break it into negative 12 and positive 7? And that's because I've been doing this thinking up here. I know ultimately I want to factor a 3 out and have a 3 times x minus 4, but that takes a little bit of pre-thought on it. But now I've got it, right? I've got 3x minus 12 divided by x minus 4 plus 7 divided by x minus 4. I'm really grouping the addition like this, right? And then I'm distributing the division to this and to that. But then I'll have 3 times x minus 4, all divided by x minus 4, plus 7 divided by x minus 4. These cancel, and I get 3 plus 7 divided by x minus 4. And there's my final answer. And it still is the same way as it was on my worksheet. All right, pause the video now and think about these a bit. All right, before I erase these, I do really want to point out that you could completely do these with polynomial long division. In fact, now that you've had a chance to kind of look at that, let me just for a moment erase some of this, all right, and show you that you could definitely do this one, because I know that this one's fairly challenging to do that way. You could definitely do it this way. And you could say, well, all right, I'll put a 3 here, right? 3 times 4 will be 3x minus 12. I then would have to subtract. Again, we got that whole negative thing going on, so maybe I'd do it this and this, and add. These two would cancel. I'd get 7, just 7, and that would be my remainder. So I'd get 3 plus 7 divided by x minus 4. That's a completely okay way to do it. Many of you will probably look at that and go, wow, that was much easier. That's fine. But I want to show you both methods in case one type of manipulation seems easier than the other one for you. All right, pause the video one last time, think about this, then we'll wrap up the lesson. Okay, clearing it out. All right, there is a big focus in Common Core math, especially high school math, trying to make parallels between integers and polynomials, and then between fractions and rational expressions. And we've been doing that all along with the simplifying, the adding, the subtraction, multiplying, dividing. And today, we reviewed how to do long division with integers, and then we extended that to dividing polynomials by one another. We'll look in the next lesson at this one more time and see how it's used in what's called the remainder theorem. For now, though, I'd like to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.